Intermediate Algebra Section 2.3. In this set of problems, they're asking us to find the slope. And the easiest way is to compare the linear equation with the standard form of slope-intercept form, which is y is equal to mx plus b, where m is the slope. This first example is in the form of y by itself equals something times x plus b, and to find the slope, which is the value of m, all we need to do is read the coefficient of x, which is 3, and we're done. In this next example, it's function notation. Well, function notation can be replaced with y, so we have y is equal to 1/2 x, and again, to answer the question, what is the slope, we can compare this to the standard form of a linear equation in slope-intercept form, mx plus b. There's nothing being added on here. This would determine our y-intercept, but we're only interested in these problems of identifying the slope, and as long as y is by itself, we can pull off the coefficient of the x term to answer the question. So we end up with slope is equal to 1/2. In this next example, they're asking us to determine the slope here, but we need to do a little bit of work, and as it turns out, y is not by itself, so we need to first get y by itself before we can answer the question. So one option would be to subtract a 4x from each side. That leaves a negative 5y, and since we have that slope-intercept in mind, I'm going to put the minus 4x first and bump that 20 behind it. Next, we want a coefficient of 1 on our y, so we need to undo the multiplication with division. And to maintain equality, each term needs to be divided by negative 5. The negatives cancel out. 5 over 5 is a 1 times y. Negatives cancel out. 4 divided by 5, we'll just leave it as that fraction times x. And a positive divided by a negative is a negative. 20 divided by 5 leaves a 4. We now have it in the y equals mx plus b, or the slope-intercept form, where we can readily pull off the slope or determine the slope by looking at the coefficient of the x term. So the slope for this equation is going to be 4/5. Rise 4 for every 5 that we run. In this next example, they're asking us to find the slope as well. And similar to the last problem, y is not by itself. And it's no problem having the y on the right. We need to get rid of the 6x, and when we subtract 6x from 6x, 6 minus 6 leaves 0x plus 4 is equal to 3y. And I'm going to leave the 0x for a minute. We don't have y by itself yet, so we'll divide every term by 3 so that we have a coefficient of 1 on our y. 0 divided by 3 is still our 0 times x, plus the 4/3 is equal to y. Ultimately, this equation is y is equal to 4/3. 0 times x is 0, so we end up with y is equal to 4/3. This is a special type of line that we will take a look at in the near future, but our mission right now is to determine the slope of this line, and we have it in the form of mx plus b is equal to y, where our coefficient on the x term is 0. So we have a slope that is equal to 0 for this particular equation. Now, if we wanted to take a look and graph this, regardless of what our x is, y is always going to be 4/3. So let me sketch in a coordinate system here. If x is 0, y is 4/3, because 0 times 0 is 0, y is equal to 4/3. So 0 and 4/3 would be 1 and 1/3. If x was 1, 1 times 0 is 0, y is equal to 4/3. Regardless of what our x is, y will always be 4/3, and we end up with this perfect horizontal, if I can draw a straight line and connect those points, horizontal line. What kind of steepness do we have on this line? Well, slope is a description of rise over run. And if we describe the rise between these 2 points, there is no rise. Run-wise, we've run a positive 1 from here to here. And 0 divided by 1 is equal to 0. So there's kind of an explanation of what's happening when we have a slope equal to 0 on an equation. We also have, not here, but we will see if we have a vertical line that we have no slope or an undefined slope, and something to look at in another problem later.